Finally, the values identified earlier, such as eccentricity, straightness, or reach, that were calculated for individual start points, can be plotted across the whole network. Rather than calculating everything in one go, we will save the values for each instance and use the animate slider function to iterate through all the points. Saving the values could be done with Grasshopper's data recorder component, but this is not ideal for such a large set. Instead, this script will write the data into an external CSV text file that can then be reopened at any later date without having to recalculate everything. First, set a file directory and adjust the name if necessary. Click the button to initiate the file. The number of lines is taken from the number of vertices. Check the read text file component by toggling the refresh to true, and there should be the same number of values in each of the outputs. The -1000 value is a placeholder for values that are not yet recorded. Turn the toggle back to false. Enable the write values script and set its toggle to true. Note the number of lines again and set the max value of the point index slider to 1 less than this value. Remember, the first index of a Python list is 0. For eccentricity, ensure the depth limit is set high enough to include the entire network. Now animate the slider. It is not necessary to keep the image, so this can be low resolution for speedier processing. The frame count should also be equal to 1 less than the number of lines. After this is run, the CSV will be filled with the recorded values. Refresh the read text file component and the values can be visualized. Note that when the depth limit has been set to include the entire network, the count and reach values will be identical for all points, and straightness will also be less variable. It can be useful to export a second file to record these values with the depth limit set to a smaller threshold, and then combine the values into a single visualization.